Assalamualaikum and good morning. First of all, let me introduce my team. My name is Nafatia binti Amreza.
Hi, my name is Ain Farhan binti Amran.
My name is Nurfar Shuhada binti Amsinan.
Today, our presentation will be focused on sustainable urban system drainage for flood management at City of Elmina, Shah Alam, Selangor. First of all, I would like to give you an overview background of site. City of Elmina is a residential area which is located in Shah Alam, Selangor. This place has applied the sustainable urban drainage system for flood management. This project 70% already complete and has been started in 2014 until now. Basically, Elmina is a green area, so development using a lot of natural material. This is for creating a nature-friendly and cost-efficient. Next, general planning and design consideration. There are 5 elements catchment to managing flood risk. First of all, detention pond, culvert, Subang River, bioretention area, and swale. First of all, detention pond. As we can see, we can refer to figure 1.0 plan of detention pond. Detention pond is designed a wet pond to control stormwater quantity impact resulting from larger urbanizing catchment. As we know, Elmina using cup drain and channel drain. The water path from this drain will flow to the pond. The pond reduces flood peak discharge downstream by temporary and gradual release using control outlet which is covered, located at the base of the embankment. Slowing water down allows silt to drop to the bottom of the pond and give plant and the organisms they support an opportunity to remove pollution. The residency time can be enhanced by extending the road of water to Subang River. Next, bioretention area. The city of Elmina used permeable system. As we can see, figure 2.0 blend of permeable system, which is drain the water through the filtration media and sandbed layer before spreading to the surrounding native soil and finally recharging groundwater. This system is applied at parking lot and residential basin. Lastly, swale. Swale are broad and shallow channel designed to store and or convey runoff at a non-erosive velocity as well as enhance its water quality through infiltration, sedimentation, and filtration. Swale may be covered by dense vegetation, usually grass to slow down flow and trap particle and remove pollution. There are some advantages of swale, for instance, low capital cost and easy to incorporate into landscape. Next, catchment characteristic. This area proportion of permeable surface, the rate of runoff will be lowest, as will the volume of the runoff and peak flow. In addition, rainfall statistic with an average daily maximum temperature of 33 degrees, Selangor is one of the warmest regions in Malaysia. It is warm to hot all year round, inviting bathing at average water temperature of 29 degrees. A rain is a day on which at least 0.1 millimeter. It does not have to rain the whole day, so they can complete this project with quickly. Next is consideration future development. As we know, population growth and development within the new town are principal factors to be considered. So necessary to plan an overall drainage strategy which will to allow the sewer to be construct economically and pass in conjunction with the growth of the town. Lastly, for general planning and design consideration is public safety. There are 6 elements for public safety. Firstly, railing on crossing, head wall, step slope where the public could fall into drain or water bodies. Second, greatest over open the drain and manhole. Third, limiting the depth of open drain and pond. Fourth, maximum flow velocity criteria for engineering waterways. Next, maximum velocity depth criteria for flow on or across road. Lastly, land grading criteria for different stormwater structure.
So I'm gonna continue this presentation with construction of drainage. The construction of drainage use precast open drain. So open drainage system. Road surface need to be free of standing water to ensure safety. It is because to intercept surface and watershed runoff into design channel for discharge into river or natural waterways. If water not systematically removed from surface drainage, this water can accumulate underneath and weaken the pavement structure. So this is the example photo of the project. In the open drainage, we have PC slab cover, PC slab seating, RC strut, brick wall, and the last one is drainage opening. So here's installation of precast open drain. First, we need leveling work to carry out to ensure suitable area. And the second step is dug a trench on both sides of the precast concrete drain using an excavator, allowing for the necessary thickness. And the third is excavate soil for installation precast concrete open drain to the required depth. Then compact hardcore to the required thickness and lay 50 mm thick sand blinding on the hardcore for ground support. After that, place a precast concrete open drain by excavator and use spirit level bubble to form drain gradient. The next one is fill the gap between precast concrete open drain with cement mortar, then compact soil inside precast concrete. The last one is finish work for installation precast concrete open drain.
So, for the drainage system, the first is crepe gully. Crepe gully. Rainfall will flow through rainwater downpipe to the stream drain. After that, water flow from the residential area is channeled through precast concrete channel, and then the water will collect the float gradually soaks through holes into the surroundings or to natural waterways. The second is roadside gutter. The side gutter provided parallel to the road for the purpose of collecting and removing surface water. Side drains typically installed alongside road with shallow design, depth and moderated traffic channel to the first point. Then the water that link to roadside gutter then will flow to the retention point, which is the design were to low wide waterway enclosure. For the retention point, a high upstream water surface elevation may also produce full flow. The next point is natural waterway. Natural drainage allow stormwater to soak into the soil. This reduces the risk of combined sewer overflows (CSOs) on rainy day. Lastly is wetland. This runoff flows over wetland and moves to the nearest channel. Channel conveys this runoff to the lake, ponds, or river, and ultimately to the seas and ocean in the form of streams, which are Sungai Subang, Panajaras, both Hulu and Hilir. So, I will explain about the element used in Elmina. First is vegetative filter strip. Vegetative filter strip designed to infiltrate water into the soil and roots for sedimentation and slow down the release of stormwater to the other side. The second element used in Elmina is natural waterways. So this is our part of the Earth natural drainage system actually. The part of stormwater that does not immediately infiltrate into the soil become runoff. This runoff flows over the land surface and moves to the nearest surface or channel. The last element used in Elmina is gabion cage. The rock deflect the impact of the waves, and the gaps between them traps and slow the flow of water, dissipating the energy from the water.
Okay, for the maintenance, first, every month, check for rusting or leak in gutter. The second one is make sure all the drainage are not clogged with garbage. So for the recommendation is just wearing safety equipment such as vest, hat, and boots when working.
To sum up, sustainable urban drainage in Elmina is more efficient and cost-effective alternative to traditional drainage control methods that integrates traditional hydrological principles and other drainage methods along with new drainage methods to achieve the drainage objective in urban areas.
That's all. Thank you.